Hello again, and welcome back to another FMOD and Unity tutorial, where today we're diving back into the 2D game kit after a little bit of a longish break. We're going to be looking at how we can attach audio to Unity's particle system. So whenever a particle collides with a surface, we can trigger some audio, which is something we haven't done yet, so it should be fun. Before we start, as always, I just want to let you guys know that the FMOD and Unity Essentials course is between 3 to 4 days away. It depends when I upload this video, but it's very close. It will be released between the 3rd and the 7th of February. So if you're looking for a way to improve your audio skills and really up your game and learn how audio gets implemented into a game using FMOD, then this might be your best bet. Okay, so let's dive into this video today. First of all, thank you, Grandpa, for the suggestion. You know who you are. Really appreciate that. So it turns out in this scene that we've been messing around with, there are little water drops that fall from the ceiling to give the impression of like a wet, damp cave. And one of the commenters who's been following along with this series asked if there's a way of putting audio to those water drops. To be honest, I didn't even notice they were there until he pointed them out. So that's what we're going to do. We're going to find those water drops, learn a bit about them, and then add some audio to them. First, let me quickly show you these water drops I'm referring to. So in the hierarchy tab, I'm just going to search for water drops and click on one of these objects. I think this is the first one in the scene. Okay, and now we should, there we go. So now you should see some water falling from the ceiling. Now, what this is a prefab of an object that has this component attached to it, Unity's particle system. Now, in case you don't know, a particle system, to put it very simply, is a way of creating loads of, I don't want to say game objects, but loads of images, I suppose, at once. They're commonly used for things like fire, for electricity, anything where you need loads of things kind of moving around in a sort of random, smoothish kind of motion. I tell you what, I'm struggling to explain it, so what I'll quickly do is I'll try and create one for you so we can actually see what a particle system straight out of the gate looks like. So if I click particle system, there you go. So as you can see, what it does is it just kind of generates a load of shapes, and until you tell it otherwise, it will disperse those shapes randomly around a center point in your game world. And you can change the color of them, you can change the shape, the size, you can change how long they last for. You can change what direction they go in. You can change pretty much just about anything of them. And these water drops are basically utilizing the particle system well, let's click back on the water drops out, shall we? They're utilizing the particle system to not only create this dropping effect, but they're also using it to trigger a second particle system to activate, which imitates the splash you'd expect to see from water dripping from a ceiling. What they've done is once they've told the particle system how they want it to behave, as you can see, they've told it to basically just shoot out one particle every second or so and send it straight down. What they've done is they've actually attached a sprite to the particle, so just a little image of a water drop to make it look like water's falling from the ceiling. And throughout this level, as you explore it, you'll see loads of water drops falling from the ceiling. The further down you get into this kind of cave, the more you start to see. So yeah, this should be fun. We've not really used the particle system before. So yeah, now that we know what we're working with, I'm going to show you my FMOD project and just show you the event I created for these water drops. It's a pretty simple one. All it is just a multi-instrument with just about 5 or 6 water drop sounds in. So let me quickly play you the event. Okay, so now that we know what they sound like, let's quickly take a look at the event that's playing them. The first thing I did was just pull the level down on the volume a bit, because these are obviously meant to be more of a background detail. We don't really want them to draw the player's attention to them too much. We just want them to sit relatively low in the mix. And like I said, just add a bit of detail to the scene. So I brought the level down, and they were originally quite loud anyway, so they needed to be brought down. If I click on the track, I've also EQ'd them quite heavily, because these recordings I didn't record myself. I just pulled them off the internet, and they were very bottom-endy for water drops, which I thought was weird. But anyway, pulling or removing most of the lows and the mids kind of helped them feel a bit more distant, so that was good. I also added a reverb just to give them a bit of character and make it sound like they're a bit more, you know, coming from a cave. And actually, cave reverb is something I kind of want to save later for, like, creating a big room reverb or a reverb area that when the player walks in, all sounds around them are affected by the same reverb. But for now, I just thought I'd slap it on the event, and maybe I'll pull that or I'll remove that later on when we eventually look at reverb areas. For now, doesn't do any harm. What else? What else? What else? Did I add some? Or no, that was some automation I was messing around with, but we don't need that. On the multi-instrument itself, I just added a bit of pitch modulation, very tiny bit, just so they don't sound too similar when, they're playing over and over again and they're randomly being selected. Obviously, we want these to sound different every time. The final thing I did was tweak the distance attenuation in the spatializer. Now, obviously, we want these to be three-dimensional. When the player is to the left of the water drops, we want to hear them coming from our right, and vice versa. When the player's to the right, we want to hear them coming from the left. And this took a little bit of tweaking, mainly because, again, when it comes to all of the objects in this game, everything has, obviously, its X and its Y coordinates, but in terms of the Z-axis, it's all 0 because it's a 2D game. We're only really focusing on the X and the Y-axis. But the only thing that is or isn't rather on 0 on the Z-axis is the camera. That's actually pulled back. So that's at about -13 on the Z-axis, so that it can see everything within the scene. And because of that, we kind of have to consider that with our maximum distance. Obviously, when it comes to distance attenuation and the spatializer in general, we're measuring distance from the studio listener, which is attached to our camera. That's what FMOD uses to calculate distance. So because it's got that distance constantly of 13, even if the player's standing on the water drop or in the location of the splash, we kind of need to set the minimum value of the distance attenuation to about -13. I found about -10 works just about right for this. And for the max distance attenuation, I've set to 25. Notice how this never drops off to -infinity. This will always play. So in theory, even if we were, I don't know, like 1,000 miles away from the water drop, it will still be playing and kind of still be heard. But there's some clever trickery I'm going to do with our script to prevent that from happening. And I'll explain a little bit more why I've set it up this way as we get to that part of the script. But when it comes to adding your own sounds to these water drops, obviously you're not going to be using, well, you might end up using these same samples. Like I said, I just pulled them off the internet. But if you do use different samples, you'll probably have to find your own settings for the min and max distance as well as the level. So that just takes a bit of adjusting and testing in the game. But anyway, that's the event. Let's have a look. Let's jump back into Unity. And, well, first, no, I'll tell you what, we will jump into the script. So on the water drop game object, and actually on the water drop prefab, if I quickly search for it, this one here, water drop. So what these objects are, they're just a copy of this original prefab here. So all the changes I've done, I did to this prefab. And then once I saved that, they were made to all of these copies of the water drops prefab. So obviously that saves me going through all of these manually, making these edits, and also the edits are consistent. So what I did with the prefab, and I won't bother opening it because it's on the same as all of them, but what I did is I created a script called water drop audio and attached it to the game object. Now let's open up the script and let's walk through it. So the first thing to note is that we are only using one function, and that's a function we haven't come across yet. That function is the on-particle collision function. Now this function will trigger, so long as you've set some specific settings to your particle emitter, it will trigger whenever a particle from the emitter collides with something physical, something with a collider in your game. Now in our case, let's go back to Unity, that's going to be when the water drop hits the ground here, hits a platform. That's going to trigger our function. And like I said, this function only works if you've got some specific settings in your particle system. The first one is you must have this collision tab ticked and activated, as well as I believe you need to set type to weld. Mode obviously depends on the game you're working on, and I think the rest doesn't really matter. The rest, other than this bit here, send collision messages. If this isn't ticked, then your function isn't going to run. So make sure they are those settings are correct. When you dive into your particle system in this project, you'll probably see that send collision messages is not ticked. So just make sure that that box is ticked. And again, obviously, open up the water drops prefab and make these changes, so it saves you going through all of these copies of it and making the changes slightly different. Now, this bit doesn't necessarily have to be set to anything specific, but it is important for us to know. They've set this, the developers of this game have set this particle system to only collide with objects in the platform layer. Now, we've looked at layers before. We've done it, I think, with the footsteps and maybe a few other stuff. But if I quickly click on the object that it's colliding with, it's this kind of tile map here. It's kind of like one big object that kind of covers the whole map, and it's a surface that the player can kind of walk on, and all the physics objects sit on top of. If you look at the top here, the layer is platform. So we know that if the particle touches any of these squares, it's going to trigger a collision, which we can do stuff with. The other tab you need to make sure is active is the render tab, I believe. As far as it comes to the specific settings, I just think this needs to be active for this to work. I was fiddling around with the different render mode. I don't think that makes a difference. Yeah, just as long as this is activated, I think this should work. What I'm going to do to make sure I've got this right is actually link you another video underneath this one that will tell you which settings you need to make in the particle system in order to ensure that your function will activate. But as far as I'm aware, collision just needs to be active. Oh, sorry, collision needs to be active, send collision messages needs to be active, and render needs to be active. And then with that, you should be good to go. So now that we know that the particle system will trigger our function, let's talk a little bit more about it. So like I said, whenever a particle being emitted from that system collides with anything on the platform layer, this and everything inside this function is going to run. Now, when I first did this, I was hoping this would be just as simple as entering a play one shot and we'd be done. Because if you think about it, if this function is going to trigger whenever that water drop collides with something, that's really all we need, isn't it? We just need to say, play the event, we're done. Pack up, roll credits, we're good to go. And as you can see, I did eventually use a play one shot, but we have to do some calculating first in order to ensure that not only our player hears the raindrop, but also kind of hears it from the right location and doesn't hear any other raindrops where they shouldn't. Now, obviously, by now, hopefully, you'll know that the play one-shot function that FMOD provides us with, for it to work, it needs two arguments. It needs the name or the event path of a function. As you can see, I've given it mine here. This is my event I'm using, water drops. And it also needs a location, especially if you're using a 3D event, which we are. So we need to tell it where we want FMOD to play that function in our play that event in this world. Let's go back to Unity. Obviously, the place we want it to play is here. We want it to play at the position that the particle is colliding with the platform. And obviously, if I quickly zoom out and highlight all of these as well, I didn't quite. Oh, there we go. You can see it. So, and obviously, we want each copy of the event to play at each of these points where these particles are colliding with the platform, okay? Now, when the particle does collide with the platform, what it's doing, as I think I mentioned earlier, is it's triggering another particle system to trigger and activate. And this is done inside the sub-emitters tab of the original particle system. As you can see that when it collides with something, it's triggering a different system to activate. This time, instead of water drops, which is the drop falling from the ceiling, it's activating water splash, which is attached to a game object that is a child of the main water drops object. So originally I thought, brilliant, all we need to do is tell it to play this object, or sorry, all we need to do is tell our event to play at the location of that splash, that second particle system, which I thought would be where it's happening, but it's not. It turns out that the particles, both of them, are located in the same space, and that goes for all copies of the prefab. I'm assuming that they've just told the system to shift by a certain amount of, or rather, whilst the object doesn't need to be in the location of where the system will play, you can tell the system to play wherever you want, really. So in this case, once that collision is triggered, using this tool, using the particle system, you can tell it to play the particle system at the location of that collision. And sadly, we can't, whilst we can trigger stuff when that collision happens, we can't tell our audio or anything really to do anything specific at the location of that collision. I mean, we can. There are ways of doing it, but it just involves, because obviously most particle systems, as you saw earlier, they shoot loads of particles at once. Because there could be loads of collision happening during the same frame, you kind of need to use things like lists and arrays, and you need to kind of group all of these collisions at once. And then using index, you have to say, right, which collision are we interested in? Is it the first? Is it the third? Is it whatever? Now, in our case, we've only got one particle colliding and, at a time, and there's a big gap in between those collisions. So it doesn't really make sense for us to use these big tools, which would take up a lot of code, when we just want to tell a little bit of audio to play at one specific point. So we're going to do something else. The way we're going to find our location that we want to play our audio at is using a Raycast, and we've used Raycast before. As you know, a Raycast is just a line, basically. It's an invisible line you draw in your game. You fire it in a specific direction, and then you wait until it hits something, and then you take the information from whatever it hit. In our case, we're after the location that Raycast hit. And as you can see, that is the first line of code. That's the first thing that happens when this function is triggered. So when that raindrop collides with something of the platform layer, this Raycast is going to be fired. And it's going to be fired from the game object that's emitting the particle straight down until it hits something of the same layer, which we know was platform. So I've created a variable of the Raycast hit 2D type and called it hit. So that means all the information that a Raycast collects will be stored inside of this variable. And then I've set it to a specific Raycast. So using the physics 2D class and the function that lives within it, Raycast, we can give it a position to start the line from, which is just, like I said, it's going to be the position of the game object emitting the particle. So we can just take its transform component and take its positional coordinates. Well, sorry, this is the wrong one. Water drops. Here we go. We can just take its positional coordinates. Then we need to give the Raycast a direction. And we've done this before. There's certain shortcuts you can use if you want to tell a Raycast to fire in a simple 2D direction. If we want us to fire straight down, then we can just write vector3 down, and that will tell it to fire down. Now we could tell this Raycast to fire for a specific distance, but we're just going to fire it forever until it hits something. So because of that, we didn't add a value for distance, we just left that blank, and we moved on to the layer mask section. Now we've looked at layer masks in code before in this series. The way we did it last time was we hard-coded, I think it was with the footsteps actually as well. We were looking for probably the same layer actually. We were looking for the platform layer with our Raycast, and we hard-coded it into the script using basically a way of writing binary. But that was long and confusing, and I found a simpler way of doing it, so we're going to do that. So because we don't want this Raycast to stop and give us a point in space when it hits just any object, we need to tell it which objects we want it to stop at. We want it to stop at any objects within the platform layer. So in the layer mask section of my Raycast, I've wrote layer mask dot name to layer, which is a function within the layer mask struct that kind of collects, it kind of holds all the different different layers you've created in your project. Name to layer, what that's going to do is basically, if we give it a name of a layer we're after, it's going to give the Raycast that layer in the form of a value, a number. If I go back to our layers, we can see that the platform layer is number 31. So because the Raycast requires the layer in its number, and sadly we can't just write that number, it's not as simple as that. What we're doing is just saying this is the name, work out the number for yourself, essentially. So that's a nice easy way of entering a layer mask. Brilliant. So we've now got a Raycast, and it's gonna, as soon as it hits a platform, we can find information out about that platform by checking the hit variable. So what we're going to do is find its location. So to do that, I've created a vector2 variable of the splash location. So a vector2 variable will hold two numbers, a number representing the x coordinate and one representing the y coordinate. We could have done a vector3 holding the z coordinate too, but like I said, the only object I think anyway, in this game that is not on it's not 0, the z-axis of it is not 0, is the camera. Everything else is going to be 0, so we know it's going to be 0. There wasn't any point. But anyway, we set the value of the splash location variable to the point that the raycast within the hit variable hits, basically. So point gives you coordinates of the vector 2 type, so 2 values, x and y. And yeah, we're storing it in a variable to use later. So in our case, obviously, because we're firing the raycast from this area here and all the other areas in this game where we've got water drops, they're going to fire straight down. They're going to fire the closest platform where the drop is inevitably splashing. And yeah, we're gonna find that location or the coordinates of that location in this scene. Brilliant. So now we can play our event or our audio from a specific location from where the drop is going to splash. So that's one problem sorted. The second problem, and for this I'm going to have to go back into Unity to kind of explain a bit more. Let's quickly highlight all the water drops again. Hopefully you'll see a few around this area. Oh, whoops. Let me do that again. Click, hold shift, here we go. So let's say the player was standing about here. Obviously the 2 water drops that we'd want them to be able to hear are these 2 here, the one to the left and to the right, okay? And that's because the player will be able to see them. Obviously the camera will be a bit more zoomed in. They'll only be able to see these 2 drops, so it makes sense for them to be able to hear them. We don't want them to hear this one here, because obviously the player's not meant to see that water drop. That's on a different level. So yeah, we want to make sure that we adjust our min and max distance or attenuation so that whilst the player is close enough to these 2 drops, they're far enough away from this one to not hear it. The problem is that you can't do that, because I think after all the testing I tried, it doesn't matter where the player is or where you set your min and max distance to in terms of volume attenuation. This drop here, this location here, is always going to be close enough to be heard. If you brought it really low so that, you know, this point was too far away, you're also making this point too far away as well. Or if the player was close enough to hear this drop, this point here would be too far away. Hopefully that makes sense. So the way to fix this is we're going to use our code and we're going to tell our script basically if the sort of collision that's happening of all these, let's zoom out again, of all these water points, if the collision that's happening cannot be seen by the game's camera, then don't bother playing the audio, because the player's not going to see the water drop. We only want to play audio for the water drops that the player can see. Which again, if I go back into FMOD, again, that's why there's no point on my distance attenuation where the water drop will ever be set to -infinity. In theory, the water drop could be 1,000 meters from the player, and it would still play, but thanks to our code, the code's going to say, well, don't bother playing at all. You know, you're far enough away, and whilst the volume's going to drop, don't bother playing, because the player can't see the drop, and therefore there's no point them hearing it. I hope that was a bit of a ramble. Hopefully that made sense. Okay, so how do we go about doing that? Well, first things first, we need a reference of our main camera. If I go back into Unity, our camera is attached to a specific game object. Let's see if we can find it. Should be around here somewhere. Here we go. So there's a game object called cameras, right? Now within that, we've got another game object called main camera, and this has the camera component attached to it, and that's what allows us to see in the game world. And as you can see in our scene tab, in our editor, we get a little preview of what that camera can see. And this has obviously been hooked up to follow wherever this sprite of Ellen, this game object of our player, goes in our world, the camera's going to follow it. So we're going to see the area surrounding the player, basically. Now what you can do, and I thought this was really cool, I didn't realize this was a thing. What you can do is you can take points in the game world on the kind of graph that exists in this game world. You can take points that are within the view of the camera, and you can take the coordinates of it in the world and translate it into coordinates of the camera. Now that might sound a bit confusing, so let me explain. What I'm going to do is I'm going to zoom in to, let's say, yeah, Ellen's a good example actually. So let's say the player character Ellen herself. Now here we can see her world coordinates. So at X she's set to -3, Y she's set to just under 1, and Z, like I said, is 0. So that's what she is. In the grand scheme of this scene, that is her positional coordinates. As you can see by this thick white line, or these two thick white lines that run perpendicular to each other, this point here is 0x, 0y. And obviously where Ellen is, that's -3, just under 1 for the Y. So that's where she belongs in the game world. However, in relation to what the camera can see, from the camera's perspective, the camera has its own kind of 2D graph. And anything it can see, it can place on that graph and give it a new location. So for example, in terms of the camera, Ellen, because she's in the center of it, is actually located at a value of 0.5x and 0.5y. So I'll tell you what I'm going to do is stretch the camera out and make it bigger so we can kind of talk about this in a bit more detail. So imagine that this line here, that's the y-axis of this 2D graph, right? And the one that runs along the bottom is the x-axis. Now here in the bottom left corner is the coordinate 0, 0, and in the top right corner is 1, 1. So if we go along the x-axis at the bottom here, if you follow my mouse, about halfway is 0.5 on the x-axis. Then if we go halfway up the y-axis, we get 0.5. So if anything in the camera, or if the camera can see anything dead in the center, it will be represented by x 0.5, y 0.5 in this kind of imaginary graph that follows the camera. Then anything in the top left corner here will roughly have a value of 0 on the x-axis and 1 on the y. Anything in the bottom right will be 1 on the x-axis, it'll be 0 on the y, and so on. So you can take any object that the camera can see and you can place it on this 2D graph. So what we're going to do in relation to the water drops, in fact you can see one here, we're going to check to see if its x value on this kind of imaginary graph is anywhere between 0 and 1. If it's less than 0, then we know it's to the left of the camera and therefore can't be seen. Or if it's greater than 1, it's to the right and therefore can't be seen. And we're going to do the same for the y-axis as well. If it's above or below 0, it's either above or below the camera and therefore the player can't see it. So if any of those conditions are met as true, then we know we don't want to play our audio because the water drop cannot be seen. In the case of this water drop here that just so happens to be falling, I'd say that there's about -1 on the x-axis and about not -1. It'll be about 0.1 on the x-axis and about 0.6 on the y. So therefore, because it's in between 0 and 1 on both axes, that means the camera can see it, and therefore we want it to play audio. If it collides with something, of course. God, I'm getting a sore throat from doing all this talking. I should have brought some water with me. But anyway, like I said, what we need is a variable representing our camera component. So we create a variable of the camera type, call it main cam or whatever you want, and using the find object of type function, we can find the object that has that component attached to it, assuming that there's only one instance or one copy of that component. Because we've only got one camera in this game, we know there is only one component of it. So now the variable main cam holds a reference to this game object here, main camera, and the component that is attached to it. Now that we've got a reference to our camera, what we want to do is we want to bring up that kind of imaginary axis that follows the camera I told you about. And the way we do that is we use this function here, world to viewport point. So this does exactly what I've just described. It's going to take something that the camera can see, it's going to take its coordinates in relation to the entire world, and it's going to translate those coordinates in relation to the camera itself. And what I've done is I've assigned whatever result that brings us to another vector. I've called it screen point, and it's of the type vector3. Now, world to viewport point is a function that returns us 3 values. Because whilst, we're mainly focusing on the X and the Y for the camera, let's go back to Unity. Also, mainly focusing on the X and the Y camera, you can use this function to find out where an object would be on the Z-axis as well. Imagine the Z-axis determines how close to or how far away an object is from the camera. So like I said, because the camera is it's 13 units away from everything else that on the Z-axis is 0, we know that all the objects in this game is basically going to be 13 units away, or the value of Z would be minus 13. But either way, we don't really care about that, so we won't be focusing on that when we do our calculations. That's just something to consider using this function, is that we do need to set it, or if we're going to store the result of this function in a variable, it needs to be of the vector-free data type. So what we do is we take the camera that we want to, do this imaginary perspective from. Then we follow it with dot world to viewport point, and then we feed it a location within our scene, and we see if and that will give us a value based on this graph that represents a camera. That location, of course, is the splash location, and because this script is attached to all of the different copies of our water drop, let's scroll out. Every time one of these drops lands, and let's make this bigger again so you guys can see it. Every time a drop collides with something in this world, it's going to take that coordinate. It's going to see, okay, where is that in relation to the camera's axis? So let's, for example, we know that the camera's roughly here. These water drops here, because they're to the left of the camera, their x value is going to be like -3 and -10. And, the further we go along, these are going to be like -20 and so on. So now we've got the point at which, so now we've got the location of all of our collisions in relation to the camera. We need to now make that check. Are they positioned between 0 and 1 for both the x and the y axis? So what I've done is I've created a Boolean variable called onScreen. So Boolean variables, we know, have to be either true or false. And what I've done is I've set that variable to these conditions here. So what it's going to do is it's going to check to see if screen point, the name of my variable that's holding a value of the splash location in relation to the camera, it's going to check to see if that if the x value of it is either greater than 0, less than 0, greater than 0 or less than 1, and if the y coordinate is greater than 0 or less than 1. And as I explained, if it is, that means it's in view of the camera. If it's anything lower than 0 or greater than 1, it's not. So if all of these conditions are met as true, then then on screen will be set to true, but all of them must be true. If one of them is false, say for example, on the y coordinates, we're in that range of 0 to 1, we're about 0.5, but the x value was -10, then obviously that's no good. So that would mean that on screen will be set to false. And with that, we're finally done. All we need to do now is check to see if the on-screen variable is true or false. If on-screen is true, then we can trigger our event to play via the play one shot function. And we can also give it the splash location, so we know that the sound is going to be played at the location of the collision. And obviously, if on-screen is false when any of these collisions happen, then this function won't run and we won't hear any audio. And with that, we're finally good to go. So now it's time. It's time. We can finally play our scene and we can have a listen to how this sounds. I'm actually really happy with how it came out. It really sits nicely underneath the mix and sort of detail. So yeah, let's check it out. Okay, so I've just started the scene. As you can see, I've got a few water drops close by that the player is about to hear. Now, even though the player is pretty close to this first one, like I said, that distance attenuation was set to about, 25 before it starts to really drop. And even then, it doesn't drop completely to minus infinity. So in theory, I'm pretty confident that that's less than 25 units. So, we should be hearing that water drop. But because in relation to the camera's perspective, it's too far away, so we don't. But if we move closer to it, can you hear that? It's very quiet. I've set it really low on the mix, like I said, because I want this to be subtle. But it is there. Let's move on and let's listen to a few more. So you should be kind of hearing some drops in the left and the right, if you're wearing headphones, obviously. Just adds a nice bit of detail. I really like this idea. Not all audio has to kind of serve a mechanical purpose. Sometimes it can just make a world feel more alive. Honestly, it's so subtle, but I really like the atmosphere that this adds. Obviously, my game's lagging a lot. Hopefully, That's not due to edits we've been making. I might have to look into that. There we go, okay. It was because I had all of these water drops highlighted and they were all rendering at once. I think that was why I was lagging. There we go, that's a lot smoother. This is my favourite bit. There's quite a few water drops around here and you can just hear the pitter-patter around you. It sounds really nice. Soak it in. Anyway, I think that'll do. I'm sure you guys get the idea by now. One last little tip, or just thing to be aware of if you're following along with this, is I found with this second water drop specifically, in fact, I think it's labelled number 15 here, is that for some reason it wasn't playing when the player was near, unless the player was like right on top of the splashdown. It turns out that the Raycast I was firing from this point was actually hitting something other than the platform. If I search for checkpoint and click on this one here, you can see that there is a trigger box on top of where this water drop is landing that the Raycast was hitting. Now, originally this was part of the default layer. And even though we're telling our Raycast to only check objects of the platform layer, for some reason it was checking this checkpoint as well. I'm assuming it's because it was a trigger box. As you can see, the collider has been set to is trigger. The idea is that the player collides with this trigger box and then the game will know, okay, they've just collided with a checkpoint. That's the new checkpoint. But yeah, whilst, you know, I kind of wanted this to be as perfect as I could, basically. So what I did is I changed its layer from default to ignore Raycast. Now, don't be so sure, don't go around changing all the layers of your objects because you could screw something up with code that needs to interact with it. I was quite confident with doing this with the checkpoint because I can't see why layers would affect checkpoints in any way. There's not many of them in the scene, and from what I can tell, it's not really affected the game in any way. So I was happy to do that. And obviously, if we were developing this game, and for some reason we had to choose between, you know, a working checkpoint or a water drop sound that played on cue, we'd definitely go for the checkpoint and we just, you know, let the water drop not play a sound whilst the player was at a certain angle. Like I said, if the player was here, you'd hear it. It was just if they were down here, the Raycast would hit this trigger box and the top of the trigger box wasn't in range of the camera, and therefore, even though we could see the collision of the raindrop, because the Raycast thought that the collision was here and not here, we didn't hear it. But that, you know, that's just something to be aware of. But yeah, we're done. So yeah, thank you very much for watching. Really hope you enjoy this, and Grandpa, if you're watching, I hope this helps. And thanks for the suggestion. As always, I hope you check out the FMOD and Unity Essentials course. That will be linked on the screen somewhere or in the description. Definitely worth checking out. Poured everything I can into this to make sure you guys, you know, can walk away from it knowing the tools, the lines of code within FMOD's API and to use in Unity, and improve the projects you work on, improve that kind of communication with developers in order to, in the end, make the end product better. So yeah, thanks very much for watching as always. I hope you've enjoyed. My name is Henry Scott, and I'll see you in the next one.